This is Module 2, Lesson 9, where we are going to talk about the sum of angles in triangles. Our standard is that we're using informal arguments to establish facts about the sum of angles in triangles. And in this one, we're going to find the angle measures in triangles using the sum of angles in triangles theorem. Okay, so I would like to start this on an activity. It's really just not online. I want to show you this. We're going to talk about what the three angles in a triangle add up to. This is a triangle because a triangle has three sides and three angles. In this case, it's angle A, angle B, and angle C. Now, we're going to prove what the three angles in a triangle add up to using a straight angle. Remember, a straight angle is a straight line. The measure of this angle is 180 degrees, right? Okay, the measure of angle is 180 degrees. So if I could cut these three angles off and line them up on here, and they added up to 180 degrees, that would prove that the sum of these angles is 180 degrees. And I've shown you that down here. This is called an informal proof. Notice I've cut off angle A, angle B, and angle C. And down here I've arranged them on a straight angle on a line whose measure is 180 degrees. If I put the angles here, if I tape the angles here, angle A, which I've cut off from up here, angle B, put it next to it, I've cut it off the triangle. Then angle C, which I've cut off the triangle and put it here. Those three angles together would make a straight angle. That means they would add up to 180 degrees. So the sum of the measures of the interior angles of a triangle equal 180 degrees. And I've shown you that right here. Now we're going to use that fact. Go to your packet. In your packet, I am on page 22. Okay, page 22. And we're going to put some properties up here just to make sure we all remember. A triangle, tri means three, angle, is a polygon with three sides and three angles. On the triangle to the left, the sides are, now remember when we're naming sides, we're using the two vertices to name them. In this case, the side would be side XY, line segment XY, okay? Bar over it means line segment. This is line segment YZ. And then line segment XZ. Now, what about the angles? In this case, the X can represent only this one angle. So I'm going to call this angle X. These are the vertices. Angle Y and angle Z. Okay? The sum of angles theorem for a triangle states that the sum of the measure of the three angles is always 180 degrees. And I just showed that to you. Okay, I just showed that to you. So now we're going to work some problems. Let's do 2, 4, 6, and then we're going to do 7 together. We know that these three angles add up to 180. That means X plus 68 plus 49 equal 180. Okay? If I'm working this, wouldn't it make sense for me to collect like terms, add up the 68 and 49? You can use a calculator for this, guys. This part will have calculator use on it, so pull your calculators out. 68 plus 49 is 117. So X plus 117 equals 180. What am I going to do to get the X by itself? I subtract 117 from both sides. 180 minus 117 is equal to 63. That means this angle here should be 63 degrees. How can I check myself to see if it's right? Add these three up and see if they add up to 180. 63 plus 68 plus 49. Does that add up to 180? Yes, it does. Okay, so your answer is 63. Now let's try this one. Now, without having to write the whole equation, what I know is these three add up to 180. If I add these two up and subtract from 180, I would get x. 34 plus 27, in your calculator, 34 plus 27 would give you 61, okay? 180 minus 61 would give me 119, okay? This angle would be 119 degrees. On this one, this angle is 90 degrees. When you have a box, it's 90 degrees. So we say 90 plus 19. In your calculator, 90 plus 19 gives you 109. I would say 180 minus 109, and I would get 71. That would be 71 degrees. Now, down here on 7, okay, we're trying to find the measure of angle 1, 2, and 3. We're going to use some information that we had yesterday, we talked about yesterday. Vertical angles, okay? Vertical angles are across from each other, and they're congruent. These two would be vertical. These two would be vertical. In this case, angle 2 is vertical to this angle 48 degrees. So angle 2 is 48 degrees. We already know what angle 2 is. Now we've got two different triangles we're dealing with. Let's look first at this triangle here. I'm looking for angle 1. I'd add up 67 and 48. 67 plus 48 in your calculator, and you get 115. To get this angle, I'd subtract that from 180. 180 minus 115. And I would get 65 degrees, okay? So this angle is 65 degrees. How can I check to see if that's right? Add 65, 48, and 67, see if they add up to 180. 65 plus 67 plus 48, they add up to 180. Now let's look at this triangle down here. We need angle 3. This measures 48, this is 90. I'd add those two together, 90 plus 48, put that in your calculator, you get 138. Now 180 minus 138 would give you 42, okay? Measure of angle 3 is 42 degrees, simple enough. Now that covers everything we want to do on that particular page. The next page in your packet is page 23, and it is a maze that you start here and figure these out. I'm going to let you work on that. What I want to do at this point is I want to go to the workbook and look at some stuff there. In the workbook, please turn with me to page, hold on. Page 146, okay? Page 146 in your workbook. Okay, this is page 146. Same problems we've been working before. You've got three angles here. Add up these two, 83 and 64, okay, in your calculator. That's 147. The three angles add up to 180, so I would subtract 147 from each side, and I get 33. The measure of this angle is 33. To check that, I could add them up. 33 plus 83 plus 64. See if they add to 180, and they do. Okay, let's add these two up. 40 plus 101 is 141. I'd say 180 minus 141, and I get 39 degrees for this angle, okay? And then on page 147, three angles would add up to 180, so 14 plus 154, if I add those up, 154 plus 14 168. Okay, and subtract that from 180. 180 minus 168 would give me 12. Let's check to see if that works. 12 plus 154 plus 14 would give me 180. Okay, and then number 7, what's the measures here? Well, all of these are x. They're all the same. The 3 add up to 180, so I'd say 180 divided by 3, and that would give me 60 degrees for each one. Now, if you do this last one, guys, this is a 90-degree angle. 90 plus 57 is 147. 180 minus 147 would give you 33. Okay, that's all of them in the workbook. There's one other thing I'd like to do, and I would like to show you how to prove that the 3 angles in a triangle add up to 180 using what we learned yesterday about parallel lines and transversals. If I have 2 lines that are parallel, and I put a line across them here, this transversal, we know what my alternate interior angles are, okay? And I've erased the numbers from here, guys, but the alternate interior angles would be these 2 that are 50 and these 2 that are 130. Alternate exteriors are these 2 that are 130, these 2 that are 50. Correspondings are in the same relative location. These 2 are 130, they're corresponding. These 2 are 150, they're corresponding, okay? We are going to use that, and this is in your workbook on page 138, okay? I need to prove that the triangle shown here, this triangle shown right here, the sum of its angles equal 180. And I'm going to use the fact that these are parallel lines and these are transversals to do that. Now, the first thing I'm going to do is I'm going to number these angles, okay? So I've got something to work with. I'm going to call this angle 1, 2, and 3. I'm going to call this angle 4 and 5. I know because this is a straight line here. I'm going to get a different color. I know because this is a straight line here that what I'm looking at right here is a straight angle. If it's a straight angle, it would add up to 180. A straight angle is 180 degrees. Okay? So what I know right now is that angle 4 plus angle 3 plus angle 5 equals 180 degrees. Why? Because this is a straight angle, okay? But what I want to say is that these 3 angles add up to 180. I want to say that angle 1 plus angle 2 plus angle 3 equals 180. This is what I want to prove, okay? Now, in order to prove that, guys, look, I need to replace some of these. I need to replace 4 with 1. Is there anything I know about 4 and 1 that will let me replace that? I know that angle 4 is equal to angle 1 because angle 4 and angle 1 are alternate interior angles. I know angle 2 and angle 5 are equal because they're alternate interior angles. So angle 2 is equal to angle 5. I know this because these are alternate interior angles, okay? Report to the gym at this time to take fall pictures. That's the case, and I can put these in place of these. In place of 4, I can put 1. That's angle 1 plus angle 3, and 2 can be put in place of 5 because they're equal, plus angle 2 equals 180. Guys, 1, 3, 2 equals 180. 1, 2, 3 equals 180. It's the same thing. I've just proven that the 3 angles in a triangle add up to 180. The most I would ask you about this would be what type angles can be used to prove that the 3 angles in a triangle add up to 180. That would be your alternate interior angles because 1's equal to 4 and 2's equal to 3. These 3 angles add up to 180. If I can replace 4 with 1 and 5 with 2, I've got that these 3 angles add up to 180. So it's your alternate interior angles that allow you to prove that the 3 angles in a triangle add up to 180. Okay? What we're using here is that the sum of the three angles in the triangle add up to 180.